Okay, so thank you very much for allowing me to Skype in to contribute. I'll give a very quick lightning round talk. I probably summarized in these 5 points. I've put the top 5 here, not the top 4 here as I did in the document. Put ion acceleration on there at the bottom, but probably the 4 points above it better represent the things I'm focused on. These are fast electron transport, ICF with particular focus on fast ignition, direct laser acceleration, generation of fast electrons, and some of the microphysical properties of dense plasmas. So just to flesh out some of those points, fast electron transport, this is mainly looking at picosecond duration beams, and it's been very heavily influenced by the prospects of fast ignition and what you need to do for that. Very heavily influenced by questions about how would you focus, guide, or collimate fast electron beams so that you maximize the efficiency of energy transports into a hotspot in compressed fuel. So there's so these two issues at the top are closely related in that sense. And then as you'll see in the project I propose, I pick up on another point in the area of fast ignition, which is not it isn't exactly the normal sort of issues in fast electron transport are focused on, but it is a very much a related issue. Other interests include direct laser acceleration. So questions about in sort of underdense near critical plasmas. You'd get in laser solid interactions at the front of targets, how generating high energy electrons from there. It's a very rich topic. There's an awful lot, although there's an awful lot to explore there, I think. The other thing is microphysics of dense plasmas. Now that follows on really from some of these earlier things. If you're looking at fast ignition, you're dealing with, or any ICF in general, you're looking at dense plasmas. And there's a number of properties you might be interested in. If you're interested in fast electron transport, you're dependent on what the resistivity of that plasma is. And lukewarm, dense plasmas, don't follow classical weak coupling theories of resistivity. So we need to look into modifying that. I have also had a long interest in ion acceleration as well. So some of that is, but I think my current focus is probably the topics listed above. So in terms of the project I was proposing, it was to look at stopping of fast electrons in compressed fusion fuel. This is really a really important topic, and certainly in the there was a while back there was a very big focus on looking at how you tackle the problem of fast electron divergence in fast ignition. And after a while, people began to realize that there might be solutions to that problem. So certainly around, say, 2013, I think this was the general feeling that this was a problem, that was an issue you could solve. But there was another problem beyond this, which was that people were of a view that probably the intensities and powers you'd need to operate at the fast electron energy, the mean fast electron energy and the energy spectrum would be too hot to efficiently stop in sort of a good size hotspot. Now, if your theory of your stopping of fast electrons is wrong in any way, then that changes that conclusion. Either way, if you don't stop them as well, it gets worse. If you're better at stopping them than you think they are, it gets better. That's it. So the prospects for fast ignition are very much changed by what conclusion we reach about that question about how fast electrons stop in compressed fusion fuel. Also, recently there has been a lot of thinking about the role of hot electrons in shock ignition and how they might contribute either in a good or bad way to shock ignition. So obviously the answer to this question would have could have bearings on shock ignition as well. So it's one topic, the conclusions of which have a lot of implications across ICF. So what I'd be proposing is sort of going back methodically and taking apart what we know of what we think we know about it at a theoretical level and looking at where we can contribute to it. So collisional stopping, collective stopping, the role of micro instabilities, so forth and so on. So there we go. I hope that was short and succinct. Are there any questions?
Well, first of all, Alex, thank you very much for taking the time out and giving this brief talk about your interests in science that you're doing. So we're going to actually go around the room or ask the participants here if they've got any questions that they would like to ask and how they would probably want to interact, but I'll give them a chance now. Kazu Tanaka, here he is, being focused in on.
I'm getting a massive zoom in here. Fantastic.
Alex, I'm sorry, I'm not Indian, but I look like a Romanian now, right? And my question is, I think your proposal is very good, and to reconsider the stopping mechanism of fast electron. But your proposal using which tool, a PIC or how are we going to proceed?
I haven't made any. No decision has been made in that regard. I want to approach it from a blank slate. Really. So first of all, it would be reviewing what we know about it and carefully re-examining it.
I see.
And then looking. So the thing is I'm not making any. I'm not trying to prejudice it in any way and say, yeah, we should use this tool or that tool or anything like that. It would be, let's review what we know about it. I mean, there's some progress has been made on this by people like Jonathan Davies, and that would be a very good point to go back and start re-examining it from there.
I see.
But go from there on.
Okay. So your proposal is maybe let's start with some thorough review.
Yeah, exactly. That would be it. Would be first of all, it would be people who are interested sit down. Let's review what we know about it, and go from there.
Okay. Thanks.
It would be as open-minded as possible, I think.
Okay. Thank you very much, Kazu. Okay, any other comments? Okay. Would you be willing to absorb some other ideas into the program of fast electron transport and ICF targets and things, and ion acceleration?
Well, say again, Bob.
As well as ion acceleration.
No. So my proposal here, Bob, was to look specifically at the fast electron stopping problem.
Right.
So I'm not sure what you. Okay.
Okay. No, I wanted the question was, would you broaden it out? But the answer was no. That's the proposal that you're going with at the moment.
Yeah, I think the best thing is, Bob, is to be focused on this. I mean, the thing is that this proposal of fast electron stopping, in my view, is very broad as it is, and it will cover an awful lot of subject matter. So I think if we try to move outside the bounds of that, then actually it would just become really quite unwieldy.
Yes, I agree with that. Right. Predomin Kaur is going to actually speak now.
What part of the stopping problem do you think is established?
Well, I mean, I wouldn't like to say at this point, but I mean, look, there's sort of classical theories that are out there, like, the beta block and all of that. You can go into Jonathan Davies' papers and look at all of that. Probably if we go and look at that aspect of it, we might not find enormous room for improvement, but it might be more in the collective area or the micro instabilities areas where we find more room for improvement. Would be my feeling about it.
Thank you very much, Predomin. Is there anything else you want to ask us while you're on Skype? Because I know you're coming back on Skype tomorrow.
Yes, quite. Well, obviously, I didn't see the rest of the lightning round, so I don't know what the general flavour has been. But are there any? What I will have seen so far in compiling things, I'll have a fairly reasonable view of what proposals have been made from the UK side, but I have absolutely no idea what proposals have been made from the Indian side. Perhaps you could give me 2 or 3 highlights.
Right. I mean, there is a lot of interest in radiation reaction. That looks like it's converging onto one area. There's interest also on plasma accelerators. That's another area.
Okay.
And there's also a very strong interest in ICF. So we've just had a very interesting talk by Predham and Kaw on a new technique to perhaps ignite or heat up the fuel when it's been compressed. So another variation of that. So I would say those are the 3 main areas. So you've got plasma accelerators with electrons and ions. You've got radiation reaction, a lot of interest in that. And then the third one would be the ICF, fast ignition schemes. So there are people that are very interested, and they've put forward a number of issues associated with that. And if we go into the microphysics, there's a lot of issues to do with the details, such as wave breaking, etc., that a lot of people have studied both in India and in the UK and elsewhere in the world. So there is I would say there's beginning to formulate groups now that are beginning to get together during the next couple of days that will thrash out some of the ideas and also make connections. That's the whole thing. That's what we're really here for, to make connections between the groups.
Okay, that's good, Bob.
Now, we'll hear from you again. So
yes.
If I know it's about lunchtime there, or just before lunch, isn't it?
It's 10:30 here.
Okay, so it's not too bad, and it's cold outside, I believe. Is it? Very cold?
Not that bad outside, actually, no. That's by my standards. I mean,
standards here.
You're out in a t-shirt and you'll be fine, Bob. That's you.
30 degrees here, so I'll let you go on that note. Actually, thank you very much, then, Alex. Thank you.
Take care. Bye.
Thank you. Bye.